Okay, so let's continue learning about lines, graphs of lines, slope, and all that. Can I draw the graph of a line that contains the point 2, 1 and has a slope of either 3/2 or -5/2? So I hope so. Slope is rise over run. Okay, so this would mean that for every horizontal change of 2, I get a vertical change of 3. So we're going to start at 2, 1. Make a horizontal change of 2. Well, if I started at 2 and I change by 2, I end up at 4. And I know that my delta y should be 3. So if I start at 1 and I change by 3, I should end up at 4. So we start at 2, 1. We start and we stop at 4, 4. And now I just draw the line connecting them like that. And there's the line going from 2, 1 to 4, 4. Now we want the slope of -5/2. So if I change x by 2, y has to change by -5. So I'm starting again at 2, 1. If I change x by 2, I still go to 4. But now if I change y by -5, I'm going to end up at -4. So to make a line of slope -5/2 that goes through the point 2, 1, we start at 2, 1. The slope was supposed to be -5 over 2. So I go forward by 2 and down by 5 to this point right here, and then I can connect them with a straight line, and there we are. Alternately, instead of -5 over 2, you can consider this to be 5 over -2. So started at 2, 1. Now I'm going to let x change by -2. So now my new x-coordinate instead of 2 is going to be 0. And now y is going to be, delta y is 5. So if I started at 1 and I change by 5, I should end at 6. Okay. Can I graph the equation x equals 2? Now this looks a little weird because there's no y in it. That actually makes it easier, even if it's a little confusing at first. Because what's a graph? I want to find all x, y for which this is true. That's true as long as x is 2, it doesn't matter what y is. So I can let x be 2 and let y be anything I want. So it's all possible points whose first coordinate is 2. It's a vertical line. It's all the points where the first coordinate is 2 and the second coordinate gets to do whatever the heck it wants, doesn't matter. Okay, so a vertical line is given by x equals a number. In the previous example, it was x equals 2. That happens to be the intercept, because if I set y equals 0, well, what's x? It's a. It's a no matter what. So the x-intercept is setting y equal to 0. Well, y isn't actually in this equation, so setting y equal to 0 doesn't actually do anything. So yes, it's already telling you what the intercept is. Okay. Suppose you have a non-vertical line, possibly a horizontal line, that's fine, as long as it's not vertical. So it has a slope. Remember, a vertical line isn't said to have a slope, or its slope is said to be undefined. So we have a non-vertical line, so it does have a slope. If it has slope m and goes through the point x1, y1, this right here is called point slope form for the line. It's tremendously useful. It's generally the best equation format to use for lines. A lot of students talking about lines go, oh, y equals mx plus b. This is something called slope-intercept form. We'll talk about it in a minute, regrettably. Okay, it is vastly inferior than point slope form. You get a lot more information out of point slope form, in my opinion, and it's a lot easier to work with later on. Okay, if the slope is m and it goes through the point x1, y1, then you just have y minus y1 equals m times parentheses x minus x1. The parentheses are terribly important. If you just wrote this, that would be wrong. You need the parentheses because that m has to multiply the whole thing, x minus x1. Okay, so here's an example. Find the point slope form of an equation of the line. Slope is 3 and it goes through the point 1, 0. Okay, so remember, I'm just going to copy it. The point slope form was y minus y1 equals m times x minus x1. So, whoops, it's right where the slide was going to write more stuff. Sorry about that. I just take that and put it in here. So y minus y1 equals m times x minus x1. the point was 1, 0, so I x1 be 1 and y1 be 0. The slope was 3, so I put a 3 here. So y minus 0 is equal to 3 times x minus 1. Honestly, if we're just looking for point-slope form, I'd say you're done. This matches point-slope form kind of exactly. Then solve for y, totally optional. I'm not sure why this was part of the problem. If I sort of go back here, whoops. It doesn't actually tell us to solve for y, it just says find the point-slope form. So I would say you're done right here. Here is the line from the previous example. It has a slope of 3 and it goes through the point 1, 0. So can we find the equation of a horizontal line containing the point 2, 3? There's a couple of ways to go about this. Horizontal lines all have the same y value. They're horizontal, they do go left to right, but they don't go up, down. So all the y values are the same. So I know all the y values are the same, and it does have this point. Well, what's the y value on that point? It's 3. So all the y values have to be 3. There's the equation of the line. X doesn't actually matter. It can do whatever it wants as long as the y value is 3. We can also, however, use point-slope form. Horizontal lines have slope 0. So here is our point-slope form. Y minus y1 equals m times x minus x1. If m is 0, notice that this whole term is just going to be 0 anyway. And what was the y value of the point we did have? It was 3. So that goes here. Y minus 3 equals 0, or y equals 3. Again, at this line, I'd say you've got point-slope form. For horizontal lines, it's pretty common to go ahead and change it to that final form there. There's the line. So horizontal lines, since they all have the same y-coordinate, it's just y equals something. And that number, here it's called b, is the y-intercept. If I replace x with 0, well, there's no x, so nothing changes. So there is the y-intercept. Okay. Here's the format that most students are most familiar with, slope-intercept form. If it has slope m, pardon me, if it has slope m and y-intercept b, then the form y equals mx plus b is called slope-intercept. So I'm just going to graph something kind of quickly here. So for example, if I have y equals 2x minus 5, this tells me the intercept is minus 5. So if I set x equal to 0, then I am finding the y-intercept. So 2 times 0 is 0. 0 minus 5 is minus 5. So this number right here immediately tells you the intercept. So I'd go here and I'd say, yay, there is 0 minus 5. There's my intercept. And now I would just put a slope of 2. And, sorry, I accidentally clicked something. And put a slope of 2, and it'll look something like that. So find the slope m and y-intercept b of the equation 2x plus 3y equals 6. Now this isn't in slope-intercept form. So we need to move it around till it looks like slope-intercept form. Okay, so I need to get y by itself. So I move the 2x over. I subtract 2x from both sides. That gets us here. I need y by itself, so I divide everything by 3. And so if I have 3y over 3 equals negative 2x plus 6 over 3, these 3's cancels, negative 2/3 x, and then I have 6 over 3, which is 2. So there's that 2 right there. So what's the slope? Negative 2/3. So what's the intercept? 2. Okay, the coefficient of x was a negative 2/3. There's the slope. The constant being added on at the end was 2. Remember, at the end of the day, we had the following. So the negative 2/3 is the slope, and the 2 is the constant. That's the intercept. So we can graph that. Here is our intercept at a height of 2. And then I make a slope of negative 2/3 by saying go over 3 and down 2. And then I can connect these points here. Okay. Can I find the equation of a line if I know 2 points on the line, but I don't know the slope? But remember, if I know 2 points on the line, I can find the slope by doing y 4 minus 2 over delta x, -3 minus 3. 4 minus 2 is 2. -3 minus 3 is -6. So that's -1/3. I found the slope. So now I know the slope, and I know 2 points on the line. Well, point-slope form actually works if you have the slope, which we do, and a point, and we actually have 2. So we can use any point we want. It won't actually matter. We're going to go ahead and use the point 3, 2. Okay. Remember, we knew the points 3, 2 and -3, 4. Use either one. Once you have the slope, you can use point-slope form using either one of those. We're just going to go ahead and use 3, 2. So here's point-slope form. Y minus the known y value, 2, equals slope, -1/3, times x minus the known x value, which was 3. There is your point-slope form. If you want to then put it into slope-intercept form, which I would consider totally optional because it didn't actually tell us to, it just said give the equation of the line, and we did in point-slope form. If you really want to put it in slope-intercept form, which you don't have to do, I am not a stickler for this, well, you can distribute out that -1/3 and then move the 2 over and get right there. Okay. I'll start a new video to discuss the general form of a line. Again, it's been about 10 minutes. That's a good length if it's a good place to stop, and I think it is. So come back for the next video to learn about the general form of a line.